I'm Joel Stauber. I'm Site Development Program Manager at Argonne National Laboratory. My role in the project has been related to site location of the facility and also overall campus planning, including sustainability.
Hi, I'm Tim Tracy with Smith Group JJR. I was the design principal for this project, working with the lab and the design team to bring the building to life.
Hi, I'm Andrew Cherry with Smith Group JJR. I was an architect involved in the construction phase of the project, helping to make it a physical reality.
We're standing in front of the Advanced Protein Characterization facility on a cloudy, cold day, and everything has begun to turn color because it's fall. It's located nearby the Advanced Proton Source, a major user facility here at Argonne National Laboratory. The building is a laboratory office building that is used for scientific research. They've been able to do groundbreaking research in modeling of what proteins actually look like, which has expanded significantly our understanding of genomes.
As we studied the siting of the building, what we realized that orienting the building 15 degrees off true east-west provided us several qualities. One, it could optimize daylight into the facility. And two, we strategically located it so that it didn't inhibit future expansions of beam lines within the advanced photon source. This was very important so that as the science in this building continues to evolve, those opportunities for future developments could be realized at some time.
So by orienting the building roughly east-west, the use of natural daylight along the south face of the building, where most of the offices are located, allowed us to save significant amounts of energy, modeled to as much as 50% for that portion of the building.
We just moved inside the facility and wanted to touch briefly on some of the features of the glass. Along the south face of the building, we used an electrochromic glass, a product by Sage Glass, where the users of the space are actually able to control the opacity or translucency of the glass. This helps from an energy perspective in being able to control solar heat gain through the glass. It also helps from a daylighting and glare perspective. So this particular system is based on two separate inputs. On the roof, there are two sensors that analyze solar conditions at any given time and help to control the amount of solar gain in the offices. The daylight component, or how much light is actually hitting the work surface, is controlled by the individual users who have control switches in each individual office, allowing them to selectively darken their offices to prevent excess glare and to allow as much daylight as possible in the individual workspaces. When you're standing out in the front of the building, you'll notice that the south face of the building has a number of dark glass areas. Especially on sunny days, these become more pronounced. This is the visual embodiment of that tinted darkened glass.
We have at Argonne a program for bike share where Argonne has purchased a number of bicycles so that people can ride from building to building on a bicycle. And given the distance between buildings, this is a really helpful feature to promote alternative transportation. A second feature is the landscaping. Near the building, there are many native and perennial grasses and other plant material which are much more sustainable. So we can help to reduce stormwater runoff, reduce the maintenance cost of mowing and blowing, and it's generally more sustainable.
Along the south side of the parking lot, there's a series of bioswales, which are vegetated means of transporting rainwater. These bioswales help to filter the rainwater as it is conveyed, as well as providing a more visually appealing means of conveying that rainwater. The site lighting in the parking lot is also dark sky compliant, meaning that it provides a maximum amount of downward facing light without contributing to light pollution, which is a major concern in the metropolitan area around Chicago. If you look around, you'll notice that all of the pavement for pedestrians on the site is of a fairly light color. This matches the roof, which is also light-colored, to help reduce the urban heat island effect, a major climatological concern in the Chicago metro area. The building also has a significant amount of insulation to help with the efficiency of heating and cooling the facility. The white metal panels on the exterior also, because of their glossy surface, help reduce maintenance and cleaning costs, utilizing rain events to help keep the building clean on its own.
And in general, many of the buildings were built here in the 1950s and 60s. This building represents a new type of building for Argonne. It uses about 1/3 the amount of energy per square foot as the older buildings do.
So we've now stepped into the main corridor of the APCF. As we began siting the building and looking at opportunities to marry the two facilities together, one very important feature became tapping into some of the processed water from the APCS, allowing that to be used within the mechanical systems of the APCF so that we could really optimize efficiencies of existing systems. Within this space, looking to your right, you also have visual access immediately into the laboratory spaces. Glass panels on the interior of the building to provide daylight deep within these interior spaces was a very important feature.
The main corridor also serves as Main Street for this building and really is a counterpoint to the old 1950s and 60s building with the vinyl asbestos tile and long, narrow corridors. This is a very people-friendly space.
Yeah, it's a bit of a deeper metaphor, if you will, for sustainability. Yes, there is the aspect of environmental responsibility, but there's also the responsibility for sort of social and individual healthiness, that providing spaces that reinforce those positive attributes are very important.
As we look down the corridor, you can see a series of box-like protrusions from the lab to the offices, which carry a lot of the mechanical systems from one half of the building to the other. These systems are tied into an energy recovery wheel, which allows for the heat out of waste or exhaust air to be reclaimed and to help temper incoming colder intake air, helping to reduce a lot of the energy required to heat and cool that air. You can also, in this location, see the exposed steel structure of the building, which has a couple of unique features to it. One is that because it's exposed, we didn't have to invest the material costs or resources to help protect and enclose those columns and that structure. The other is that because there is steel structure continuous to the outside, the structure has been provided with thermal breaks to help reduce heat loss through exposed metal.
We moved into one of the office spaces where you'll see several key features. One feature being all of the offices along the outside wall have glass panels in the doors, glass transoms above the doors, and side lights beside the doors. This enables us to pull some of that natural light, and it becomes borrowed light for the open office space immediately adjacent. You'll also be able to see some of the active chill beams in this office space. Because fluids like water tend to be more efficient to move heat and cooling around a building rather than air, chilled beams use a hot or cold water loop, depending on the season, to provide more radiant heating and cooling for the space, reducing the amount of air that needs to be tempered by the building's mechanical systems. These radiant systems also reduce the amount of energy needed to heat and cool air, tempering it, as well as reducing the amount of energy needed to move that air through the use of fans. So as we look around the offices, you'll notice there's a lot of different finishes in this area. A lot of the paints and coatings within the building were selected because they have a minimum volatile organic compounds being released, the reduction of which contributes to overall indoor air quality. The carpet tiles and the furniture systems were also selected to help maximize the amount of recyclable materials.
so that when these offices are renovated in the future, a maximum amount of material can be reused.
Designing a building like this really requires a tremendous commitment from a client that sees sustainability as a key attribute to their mission. It takes a lot of work from a lot of different people from a design perspective.
As far as getting the building built, the process of constructing the building involved a fair amount of coordination and education for building trades that aren't necessarily accustomed to building such high-performance buildings.
One other consideration is that the federal government has been proactive to promote sustainability, and we've been working to meet the guidelines, which include a specific percentage, 15% of buildings that are high-performance sustainable buildings. And our objective with this building is to qualify for those ratings.